Okay. We talk a lot about atoms and their particles, and we actually use all that information to fit them together into a table that sort of organises the information for us. It's a very useful table, periodic table. So you need to know that atoms are described in this idea of electron shells. It's used in the periodic table. Apparently meant to investigate the chemical activity of metals, but anyway, we'll see about that. Explain how the electronic structure of an atom determines its position. That's the most important bit, and its properties. So, we've done this a bit. Atoms and elements. All matter is made of atoms. An element is a substance that is made of only one type of atom, and they have a letter. Now, letters now become important. These symbols are used in the periodic table to show us where each of the elements sits. So, these are things we know. We've also talked about this in previous videos. We know an atom contains electrons that are negatively charged in these shells of energy, using the Bohr's model, and we say they have no mass, although that's not quite true. Protons and neutrons are found in the nucleus. Protons positively charged, neutrons are neutral, they have no charge, and they both weigh 1 atomic mass unit. This becomes really handy when we start trying to explain where things are in this table. So, the original table was made by a guy called Dmitry Ivanovich Mendeleev. He wasn't the only guy trying to do this. There's a whole lot of scientists, and there might be some female scientists, not too sure, who were also trying to put this together, a table just to organise what they knew about the elements. Mendeleev was quite interesting because he took, when most of them were trying to use what they did know, he actually realised that there was stuff they didn't know. So he left holes for things that weren't known. And strange enough, since then, we've filled all the holes in. So his original periodic table had spaces that he knew things were going to appear, didn't know what they were, but he knew something would be in that space. Because what he's done is he's organised these things, they're numbered. There's a very good example, he should have some atomic masses as well. He's got the atomic number there. So hydrogen is number 1. It has 1 proton. It has 1 proton, has 1 electron. Helium has 2 protons. And then we jump to the other side, we've got lithium with 3 protons, etc. So these are actually listed in order of the number of protons they have, but it also means that their mass number is getting bigger too. So as we move through this table, these get heavier and heavier. So the bottom ones, in this case in this particular table, it's not quite accurate anymore, 113 is the heaviest. At this point in time it had no names, so they now got names as well. An old diagram. So the columns have similar properties. I mentioned in an earlier video that some things are very hard to make react. These guys here these are all what we call noble gases. The number of electrons they have means their outermost shell of electrons is full. Because that's full, they don't need to find an electron from somewhere else. So they don't tend to be reactive. These guys here need 1 electron, and they've got a full outer shell. They're highly reactive. They're searching for that electron. These guys over here have 1 spare electron in their outermost shell. So they're highly reactive because they can give away an electron to make a compound. We'll talk about those sort of things later too. So this table tells us heaps about things. And on the periodic table we have 3 main groups of materials. We talk about the metals, the non-metals, and the metalloids. So the metals, there's a bunch of metals here, tend to have very similar properties, usually solid at room temperature, although mercury is famously not. Generally shiny, but you can see some of them are dull. Easily shaped, so we call it malleable. So when you melt these down and create them into a molten form, before the ingot's made, you do some interesting shaping with them. Some, like copper, can be drawn out into wires, so we call it being ductile. And because of the manner in which they form, these are basically crystal structures, they can conduct heat and electricity really easily. Not all of them, but most of them. So these are the sort of characteristics that these metals contain. And most of the periodic table is actually made of metals. The non-metals are obviously the opposite. They're usually gas at room temperature. They're semiconductors of electricity or heat. So you can do things to them to make them do that, but they don't generally do it. They're brittle. So if you make them into a solid, because they're normally gases, if you correct them into a solid, they tend to be powdery and brittle. And therefore you can't do much with them. You can't shape them. You can't make wires or jewellery or whatever out of them. And then the metalloids sort of sit in the middle. There's a group that contains, not too many of them, say 9 or 10 or something, that have some metal characteristics and some non-metal characteristics. Interesting, it's a little bit of a fun fact. Adenine is so rare that it believes only 1/3 of a gram in the entire Earth's surface. It's pretty rare. So strange little objects. And that's what the periodic table is all about. Organising all the elements we know into a way that we can study them. In fact, no, that's right.